Welcome to a bonus Pomodoro Joe. Today we're looking back at LeetCode problem 1162, as far from land as possible. This is a medium problem. And in this problem, we are given an n by n two-dimensional grid, where each cell in the grid is either a 1 or a 0. 1 represents land, 0 represents water. Our goal is to find the water cell with the maximum distance from land, and then return that distance. So let's take a look at our solution so far. Now in this solution, we have an outer loop that tells us whether or not we're done, and we have two inner loops that will loop over the entire grid from left to right, top to bottom, looking for land cells. If we find land, then we just look up, down, left, and right from that land cell, trying to find a water cell. If we find any water that's adjacent to a land cell, then we will fill that water in with a new value. We can call it landfill. So that new value will be the value of our land cell plus 1, because this water cell is one more step away from that land cell, or that landfill cell. All right, we will continue to process our grid one cell at a time until we are completely out of water cells. So this is multiple passes through the entire grid. Once we're done, then we make a loop through the entire grid one more time, looking for the maximum cell, and that will represent the furthest point from land. So how did the solution do? Let's take a look. So it passed, but it only beat 8% for runtime. Beats 91% for memory, but an 8% runtime, not so great. So what can we do to fix this? Well, the first thing that we notice is we're going through this grid multiple times, every single cell. Is there a way that we can cut down on that processing? Well, every time we go through the grid, we're just looking for land cells. What about just keeping track of land cells? That way we don't have to go through the entire grid. We just have to go through our list of land cells. That would save us a ton of time, right? Let's try that. So with minimal changes, let's see what we can do. I'll put 25 minutes on the timer, why not? Okay, so let's just keep a list of all of our land cells. I'll call it a queue. So we will keep a queue of land cells, and we need to fill that queue with all of the land cells with the initial grid. So for, let's see. Well, in fact, I'm actually going to just grab this loop here, because this is what we want. So we're going to loop through the entire grid. And if any of these cells are land, we will put them in our queue. So let's see if grid. And remember, we do Y first. All right, so if we found some land, let's put it in our queue. How are we going to represent this? I think I'll use a tuple with two values. And we will do X and Y. Okay, so now we have our list of all the land in the initial grid. How do we use that? Well, instead of doing while this isn't done, let's say while we still have some land to process. So while we have a queue, and then we don't need this anymore, but we do need to grab the land out of the queue instead of getting it from the grid. So let's see, we'll have some X and Y, and that equals, we'll just pop the first value out of our queue and grab the X and the Y from that. Now we don't need this internal loop here. Get rid of those. Okay, but everything else I think stays the same. We'll need to change the indentation here. So we'll grab some land coordinate out of our queue. We'll grab its current value, make sure that we actually have land. I probably don't even need this anymore because we know it's greater than 0. So let's actually get rid of that, and we can indent all of these. All right, even better. Okay, what else can we change here? Looks like down here we don't need done anymore, but what we do need is we just found some water. That's what this represents. We found a water cell, and we're going to fill it in with some land. this becomes a new land cell. So we have to add this new land cell to our queue. So we'll append, and it looks like we just need to do chord Y, okay, chord X and chord Y. All right. And I will keep this for now. We might be able to optimize this as well, but for now, we'll make minimal changes. Okay, let's run that and see how we do. Let's see. Oh, typo there. One of these days I'll have a solution with typos. Hey, it passed. Okay, let's submit that and see if we get any improvements from making these changes. Hey, not too bad. We do drop with our memory footprint from 90, what was it, 91? 91 down to 79, but we bump up our runtime from less than 10% to over 40%. Not too bad. Let's see if there's other things we can do. Well, the one that kind of stands out here is if we can avoid this last pass, I wonder if it's possible to just keep track of our max result as we go. Let's give it a shot. I'm not sure that this will work, but hey, why not? YOLO. Okay, so if this works, that means we save one entire pass through our grid. That seems to work. Let's submit that. So it works, but it actually doesn't save us anything, which is surprising. We get 42% down from 44%, and we get 52% from memory down from 79%. So what I thought would be a pretty decent optimization turns out makes things worse. That's pretty surprising. Okay, that's it for me. Just a short bonus, just to try out a few things. I felt bad about having a sub 10% runtime from the last solution, so I just wanted to try to make up for it here. I don't know if 44% really makes up for it, but hey, it was worth a shot. Okay, folks, hope you had fun, hope you learned something, hope you enjoyed this, hope you can write a better solution than I did.